This was a 5-point problem on your test, determining the empirical formula. Of course, the number one thing that people who got this wrong did was that they used gram ratios. Remember that your formulas are not in gram ratios, they're in mole ratios. So you've got to convert to moles. These are easy in that it gives us percentages. And so anytime we're given a problem with percentages and we need to get some real numbers out of it, we can just pretend that we're starting with 100 grams of something. Okay, so carbon, if we had 100 grams of this succinic acid, we'd have 40.6 grams of carbon. We'd have hydrogen 5.18 grams, and for oxygen we'd have 54.22 grams. Now, it would be great if we could just take these numbers and do something with them, but the gram number doesn't mean a lot. What matters is the moles. We have to know how many moles of each one of these things. What's the ratio between the carbon, the hydrogen, and the oxygen? Because formulas are written in terms of moles. They're not written in terms of grams. So we're going to just convert each one of these numbers to moles. And we're going to do that by dividing the GMW, or the molar mass for carbon, is 12.01 grams per mole. Hydrogen is, I think, 1.01 grams per mole. Oxygen, 16 grams per mole. Notice that in each one of these cases, when we divide by the molar mass, we're going to end up with moles of each substance. Okay, so 40.6 divided by 12.01, I'm getting 3.38 moles. Here I'm getting 5.18 moles. 5.18 divided by 1.01, and 54.22 divided by 16, I'm getting 3.39 moles. Now remember, I may have rounded just a little bit differently than you did in your calculator, but we're going to come up with some pretty good numbers here, and that's not going to make a big difference. The next thing we do, now that we've got actual ratios to work with, we're going to write down our formula. We're going to leave some space in between each one. It's conventional to always write your carbon first, then your hydrogens, then your oxygens, then other things, sulfurs, and so on. I'm going to take this number and I'm just going to put it down here, because in this formula I've got 3.38 moles of carbon. I've got 5.18 moles of hydrogen, and I've got 3.39 moles of oxygen. Now remember, according to the law of multiple proportions, we can't write a formula like this. You've never seen like H 1.375 to O 2 point something or not. You don't see that. You see H2O. You see common whole number ratios here. So the way that we get a whole number ratio is we look at which one is our smallest number here. In this case, 3.38, and we're going to divide all of them by 3.38. We're dividing all of them by our smallest number. And what this does is this is going to give us a ratio that, should be a whole number. Okay, so this comes out to 1. This one's going to be a 1. For the hydrogen here, 5.18 divided by 3, I believe we get about a 1.5 on this one. 5.18 divided by 3.38. Yeah, we get about a 1.5. Okay, so we're still in a little bit of a dilemma, right? I mean, we never see a formula that says CH1.50. We see whole numbers. So all we do in order to get our whole numbers is multiply by a 2 here, so that every one of these will be in a whole number ratio. And that's going to give us our empirical formula. C2H3, O